So here are some of the details for 2.2.8 that we discussed today in class. So recall that A, B, and P are square matrices and P is invertible. And you're given that A is P times B times P inverse. And you want to solve for B in terms of A and P. Alright, so what are you going to do? Well, you have to remember that matrix multiplication is non-commutative in general, and so whether something happens on the left or the right, it matters. So what I want to do here, if I'm trying to get B isolated, I could multiply by P inverse on the left of both sides of the equation. And now notice that P inverse times P just gives me the identity matrix, and the identity matrix times B is just B. And now I'm going to try to isolate B some more. I got to get rid of the P inverse that's over there on the right. I can multiply both sides of the equation by P on the right. And now P inverse times P is the identity, and B times the identity is just B. And so I'm left with P inverse AP equals B. And now just remember, matrix multiplication is non-commutative in general. And so that tells us that this is the answer, and we can't just cancel the P and the P inverse. So why can't we cancel it? Well, we can't just move things in order, change the order around, and so this matrix A gets in the way. And so we can see this concretely in an example. So let's let A be this matrix 1, 2, 3, 4. P is the matrix 1, 1, 0, 1. You can compute that the inverse of P is 1 minus 1, 0, 1. And now let's just compute P inverse AP and confirm that we get a matrix that's different from A. Right? And so I multiply the 1, 2, 3, 4 matrix by the 1, 1, 0, 1 matrix, and I get 1, 3, 3, 7. And now I finish off the multiplication, and I get 2 minus 4, 3, 7. So definitely not the matrix A.